The code that you're seeing here works, but it's ugly, repetitive, verbose, totally un-Pythonic. Today I'm going to take this pretty clunky fitness tracker script and refactor it step by step into clean, beautiful, idiomatic Python. Before I start refactoring that code, let's talk about this word Pythonic. It's one of those terms that lots of Python developers throw around, but what does it actually mean? Is it some kind of secret club that only a few gurus are a part of? Or do you need to buy a bunch of ArjanCodes merch, like the hoodie that I'm wearing right now, or this nice hat, or this mug that's now available? Of course not! There's no clear definition, but to me Pythonic code is code that uses Python's strengths, like readability, simplicity, for example, in many cases using functions over classes, and expressiveness, using features of Python that are really powerful, like comprehensions or generators. And it should feel natural in Python. Well, that's not very specific, obviously. Now, the closest thing we might have to a definition is the Zen of Python. If you write import this in a Python script or in the command line interface like here, you get the Zen of Python. And this outputs a number of guiding principles like beautiful is better than ugly. Don't know exactly what that means. That's kind of up to you what you find beautiful or what you don't find beautiful, right? To me, the favorite one is simple is better than complex. And that doesn't just apply to Python, but to any programming work. And in fact, most anything that you do in life. But in this video, when I talk about Pythonic, I mean that I'm going to be using idiomatic syntax, things that fit well with Python. I'll try to avoid over-engineering and overall make the code just easier to reason about. Now, with that in mind, let's take a look at the original version of the code. The starting point is this fitness tracker class that has a log food method to log some food items. So this writes to a food.csv file. We have a log activity method as well that logs to activities.csv, and we have some method that prepares some sort of summary for the day, and then it retrieves information from this CSV file and from this one as well, and then it's going to print out some sort of summary. Some issues in this code are the manual file opening and closing, no type annotations, there's no data classes or something, no error handling, pretty verbose control flow, especially in run day summary. And the question is also what the added value of the class here is. So there's lots of things wrong with this code. I mean, it works when you run this, it creates these CSV files and it prints out a summary. And this is what these files look like. Pretty basic, obviously, but clearly there's a lot to improve in this code. So the first thing that I'm going to do to make this more Pythonic is to replace that fitness tracker class, or actually just remove it and turn these methods into functions. Because as you can see, the class has no member variables. There's no reason for this to be a class. We don't need multiple instances of a fitness tracker, so we can simply turn this into functions. So that's actually very easy to do. I just remove this and then I de-indent this part like so. And we will remove the self from all of these argument lists because obviously we don't need those anymore, like so. Now, the nice thing is at the bottom of the script, we don't need to create an object anymore. So we don't need that object and we can simply call the functions directly. So we're logging the food, we're logging activity, and we're running the day summary. Like so. And now I'm going to run the code, and as you can see, it does exactly the same thing and it creates the files again. But now we went from having this class to having just a couple of simple functions. And typically, I much prefer this kind of setup. Actually, overall, I typically start with functions and I only add classes when I feel like they add some value. On top of that, if you want to write tests for this, that's also a bit easier because you don't need to create an object. Next step is that I want to take a look at how we're dealing with files. Now, you can do it this way in Python. You can open files and close files, but this is actually pretty dangerous if something goes wrong. For example, let's say that for some reason you're not able to open a file. Or here in the run day summary, if you call that before you actually log anything, then, well, these files don't exist. Now, there is a check here. I'll come to that later. But there's all sorts of things that can go wrong here. And then if it goes wrong, we don't properly close the file. And in terms of resource management, that's not great. Now, the Pythonic way to do this is to have, instead of these manual opens and closes, to use a context manager instead. And this also makes the code look a lot cleaner. So how do you do that? Well, this line we're going to replace with a context manager. So we type with open food as f, and now we can, within that with statement, add a block where we can do something with the file. And we don't need to close the file anymore because the context manager already handles this. And the same thing, we can also do that here. And then I can delete that. And finally, we have the same issue in, of course, run day summary. So here we're going to do the same thing. But now I'm going to put the entire for statement inside the body of this with. And then I will remove the close operation here because that's not needed. Same here. There we go. That actually makes the code a bit shorter because now we don't need to manually close the files anymore, and it's going to be much more safe because if there is some error here while we try to open this file, the context manager is going to make sure that that resource is actually released. Let's run this again and see what happens. Oh, now we're having minus 400 calories because I'm actually adding this data to the existing file. So as you can see, there's now multiple entries. I ate 2 bananas and I ran twice and burned 300 calories each time. The next step, you see that my IDE is already giving all sorts of errors here, is that we want to add type annotations. Now, strictly speaking, this is of course not necessary in Python, and especially in older Python code, you're not going to see a lot of use of type annotations. And there's still plenty of packages today that don't have type annotations, even though they're very useful. I find by adding type annotations, it not only makes your code a lot easier to read and understand, it also forces you to think about what kind of thing a certain data item is. Like, for example, here, calories, we have no idea what that is. Is that a number? Is that a string? Is that a list of things? It's unclear, right? Now you have to inspect the body to see what this actually is. And it seems if you read and interpret this that, okay, it's probably a number, but it's not clear at all from the function signature right here. And by adding type annotations, it just makes it much easier to understand what a function expects in terms of data and what it's going to return. So here, let's add those annotations. And that's very simple to do. So item, for example, that's a name of an item. So we're going to make that a string. And calories is a number. Let's say that's a whole number. We don't deal with half calories, so I'm making that an integer. And then we have date. So if you look at what date actually is, you might think that is a date time object, but actually, as you can see, it's represented here as a string. So date is actually a string. On top of that, it needs to accept optionally a non-value. So it's an optional string, and we can denote that by writing string or non, like so. With type annotation, it's also important that you don't forget about the return value. What's the result of a function? Here, that's also pretty straightforward. It doesn't return any result, so we simply write none. LogFood doesn't return a value. And with log activity, we can do the same thing. So date, again, that's a string, or it's none. Calories burned, that's again a number. And the activity that we're logging, that's a string. Also, I'm not sure why there is an extra datetime import here. I'll just remove that. Finally, let's take a look at run day summary. So here also we have date. So that's also a string. There's also no return value here. It simply prints a summary, like so. As you can see, my IDE still gives me some of these red squiggly lines. I've set type checking here to strict, so I actually do see these errors, and I like that. Now, the reason this happens is because I define food here as an empty list, but it's unclear what type of list this is. This can, in principle, contain anything, right? But we're adding integers here, so that's why we get the error. In order to solve this, you can specify the type of the list when you define it. In this case, that's a list of integers. As you can see, now this error disappeared. So we can do the same thing for activity. And that is basically all we need to do. Now, type annotations are in principle ignored by the Python interpreter. So if I run this, I simply get exactly the same result. Well, it's now minus 600 because I added yet another banana and I ran yet another time and burned 300 calories. But the program does the same thing. Python ignores these type annotations. They're really there to be helpful to you as a developer. And that's also how you should view them. And by the way, if you want to learn more about how to design a piece of software from scratch, I have a free guide for you. You can get this at ArjanCodes/design guide. This contains the 7 steps that I take when I design new software. Hopefully it helps you avoid some of the mistakes that I made in the past. ArjanCodes/design guide. Link is also in the description of the video. Now, next thing that I'm going to do, and that's in this run day summary function, is this part. So what this does, this checks that food.csv exists before I open it. And it's all fine. It's a programming technique called look before you leap, right? We check if it exists, then we open it. Actually, a more Pythonic way of handling this is that it's easier to ask forgiveness than permission. And that basically means that instead of checking whether the file exists, we're just going to try and open it. And if that doesn't work for some reason, we handle the error. So if we do that here, then instead of this if statement, what we're going to do is a try except block. So that's going to be a try, and this is going to be an except file not found error. So that's the kind of error that we might get. And then we can print a message to the user. And of course, I can do the same thing right here. The reason that this is a arguably nicer approach is because you are explicit about the kind of errors that you're handling and you don't have to do all these various checks. So that's actually pretty nice. Also, in this case, it actually means we don't have to import OS anymore. Now, the next step to make this even more Pythonic is by taking a look at the structure of the data that we're using. Now, if you look at these logs, they all have the same 3 fields. There is some sort of item or description, there is a date, and there is a number of calories. So instead of passing around these 3 arguments everywhere, we can also model this in a class. Hey, and you thought I didn't like classes. So actually, sometimes I still do like classes. And I'm not just going to create a class for this, I'm going to use a data class. Like so. And then I'm going to define that data class. I'm going to call it entry. Entry is going to have a date. It's going to have a description. And it's going to have calories. Like so. And that means we can now also remove a lot of duplication, because actually logging food and logging activities is almost the same thing apart from the file name. So the first thing I'm going to do is rename log food to, let's say, append entry. And this function is going to get a file name. So we can use it for food or for activities or for anything else that we want. And I'm going to pass an entry. And that is of type entry. That's the class we just defined right here. And if you want to do it in a really neat way, you can see that there's here a part that handles when the date is none. Now what we can do instead is actually add that feature to the data class, so that when you create the entry, it will actually fill in a default date. Now in order to do that, we're going to need a helper function. Let's call that function today. This is going to return a string. And what that will do is it's going to return this exact value. And now what we can do, and I'll just move date down the list so that we can set a default value for it. Then what we can do is we can create a field, which we need to import from Dataclasses. And the default factory for this field is the today function, like so. Now, you might wonder, why can't I just call today here? Well, the problem is that it will then calculate that default value once, and then every time you use entry throughout your code is always going to be exactly the same date. This way, by using default factory, it means that this function is called whenever we create the entry object. So now what we can do is refactor this append entry function. So this we don't need anymore because that's already handled in the entry data class. And then we open the file, so that needs to be the file name, like so. And then what we're going to write is entry.date, entry.description, and entry.calories. And by the way, you can probably improve this even more by setting also default values for the description and or the calories, but I'm not doing that for this particular example. And then the print statement we also need to update, of course. So that's going to be appended the entry, so slightly changing the behavior of the code here. And then we have entry.description, we have the calories, and we have the date, like so. So that's appending the entry. Now what we can do next, that I can actually remove this log activity function, because we don't need that anymore. And then what we're going to do here is append entry, and then I'm simply going to provide the file name and the entry object. So the file name here for this is food.csv, and the entry is a banana with 100 calories, like so. And here we're going to do exactly the same thing. Append entry. Here we have activities.csv. And then the entry is running with 300 calories, like so. And then we run the day summary, and here we can actually also call the today function that we made before, like so. Let's run this again and see what happens. So you can see we added yet another banana and we started running even more, and then we have our summary just like we had before. So this is nice because now it provides a bit more structure to our code, and that's also a really nice addition when you're writing Python scripts, that you think about structure a bit, and it's going to simply make your code a lot easier to read. The next step is that we think a bit more about constants and where we define those things, centralize file paths and how we're using them. Now, if you look at the code, we, for example, here have open food.csv. Now that works, but it's also pretty brittle. Instead of defining it here as a string, it's probably better to define it as a constant at the top of the file. Now you can also load that from a config file. I like to do it at the top of a Python file if it's not too many constants. So what you can do is something like this. Like so. And then instead of referring to the string here, we can refer to the constant. And then we also do that over here. So now if you want to use a different file, we only need to change that in one place, namely here. And of course, we can do the same thing for the activities. Like so. Now, if you want to be really neat, actually, of course, these are file names currently, but it would be even better if we use actual paths, because then we have a lot more flexibility. And one neat way to do that is to use pathlib. So I'm going to import path from there, and instead of using strings here, I turn these into path objects. And the nice thing about that is that you can then combine different paths. You can create like a top level directory and then have relative paths below that. There's a lot of features in pathlib which are really nice. And what's really cool is that opening a file actually works with path out of the box. And then of course we also need to update this, because this is going to be of type path and not a string. So there we go. Let's run this and see what happens. We're already at minus 1000 calories. I'm starting to like this example. So we're using pathlib, which is a really nice addition. And now that we have these paths separately, we can also take a look at run day summary and simplify that as well. Because actually, if you look at this code, well, that's roughly the same as this code. There's just a few name changes here and there. So what we can actually do is duplicate this like so. And then we can actually just create a read entries function that reads entries from a file. And of course, for that, we're also going to use the path type. And then what we'll do here is I will just name this entries, and we're going to open the file. And then if we want to be really neat, we can start using more Pythonic style coding. So instead of creating a list of entries here that we're returning as a value at the end, what we can do instead is actually using an iterator. So what I'm going to do is read entries is going to give me an iterator of entry objects. And from typing, I'm going to import the iterator. And then what I'll do here, instead of dealing with the list of entries, I'm simply going to yield an entry object with description, calories, and finally the date. And I'm missing a parenthesis there, and I have one extra there. And this we don't need. So now we have a read entries function. And if you look at the try except block here, actually it does nothing else than just print a message. So the question is whether we really need this, right? Because if there is some sort of exception, it's already going to print some sort of message. And that's also a nice thing about using try except block, that actually often later on you can remove them again. So here, reading entries, I can simply remove this, and I'll just assume that my interpreter is going to print the error whenever I encounter one. So now we have a function for reading entries from a file. So then what I can do here is actually read food in a much easier way. So I'm just going to create a list from read entries of my food CSV file. And then of course it's not going to be a list of integers anymore, but a list of entries. And there's just one part that we don't need to forget to do a bit later on, but I'll do that in a minute. But now I can basically remove all of this. And same for the activity. I can simply create a list from reading the entries from the activities CSV file, like so. And then I can just remove all of this because that's already covered in this helper function. So then what we're going to do is now we can compute sums. For example, the food total, we can make that the entry.calories for entry in food if entry.date equals the date. That also automatically adds our filter. And here we can do the same thing for the activity, but that's going to be almost the same. Entry.calories for entry in activity if entry.date equals date. So now you see that step by step we're relying more and more on the strengths of Python by using these types of expressions, which is a really powerful feature of Python. Let's run this again, and we're already at minus 1200 calories. Yay! Now I feel that we're almost there. One other thing that I want to do is, instead of having these print statements, I want to have proper logging. That's another example of relying more on Python's standard library. And for that, we're going to import the logging module, and then we're going to set up logging. So that's a basic configuration where we log a particular level, and we also supply it with a format. So we have time and the level name and the particular message, like so. And then, for example, instead of this print statement here, we can write a logging message, like so. And then let me remove this print statement. Now here, I feel like this is actually not logging. This is really just the result of the program. So I'll leave these as print statements. But when I run this, now you see that we're going to get these logging messages, which contain a lot more detail in terms of the time when that happened and the logging level. So that's a nice thing to have as well. The final thing that I want to do is take this code and put it in a main function. Of course, the main function also doesn't return any result. So I'll indent this, so that's part of the main function. And then if name equals main, we're going to call the main function. Now, in essence, it doesn't really do anything. I mean, the code just runs exactly like I did before, but now at least we have this explicit entry point, which is nice. And also if you define some variables that you're going to need here, then it's not going to pollute the global namespace, which is also really neat. So now when we look at this final version of the code, this is actually, to me, a pretty good setup like this. We have some logging, we've defined constants at the top of the file. I have some helper functions like the today function. I use a data class to structure my data that I'm working with. I then have functions that do a particular job that I need without having too much duplication. So I have appending entries and reading entries. And then I have my function for creating a summary. They all have nice type annotations. I'm using the standard library features like pathlib and datetime, Dataclasses, logging, which is all very helpful. It makes my Python code a lot shorter. And then finally, the actual behavior of what I want the script to do is in a main function. Now, if you like these kind of refactorings and practical Python tips, make sure to subscribe. Clicking a subscribe button actually also probably burns like 0.01 calorie or something. So, you know, it's a start. Anyway, I hope this video gave you a better idea of what I think Pythonic means. But I'd love to hear from you. What are some un-Pythonic patterns that you often see? How would you refactor this code that I showed you today? And when you started learning Python, did you have habits that you needed to unlearn? Let me know in the comments. Now, during refactoring, I mentioned a few times that you should rely on the standard libraries, things like Dataclasses, pathlib, etc. Actually, the standard library is one of the best things of Python. If you want to learn more about some of the real gems that are in there, check out this video next. Thanks for watching and see you next time.